Hi guys, this is Ram from Crossmind Studio. Welcome to my new tutorial series about Blender's new feature, Mantaflow. Few weeks ago I uploaded few of my test simulations and some of you really liked it, suggested I should do few tutorials about Mantaflow as well. I personally wanted to do this series because it's a newly added feature to Blender which can be used in many scenarios such as cinematics and motion design. And since I was exploring and learning Mantaflow myself, I thought it's best time to share this tutorial while my observations are fresh. This will be really exciting series and a lot of fun. Those of you who don't know what Mantaflow is, Mantaflow is a new smoke and fluid simulation system which is now part of Blender. And in this series, we are going to introduce how Mantaflow works, both liquid and smoke system, and how you can create some useful simulations such as fire, smoke, explosion, splash, and other forms of fluid and smoke simulations with it. Unlike previous tutorial series where we had pre-decided number of chapters, this will be an ongoing series and we will keep on adding chapters to it whenever we come across a new topic or challenge worth sharing about Mantaflow. So you can keep an eye on this playlist over here and add this to your favorites and enable the notification whenever there is an update to this one. So the first two chapters are going to be about absolute basics. In chapter 1, we will discuss the basic principles and the parameters of Mantaflow and how to create a simple flow source and make a simple fire and smoke simulation, something like this. In chapter 2, which will be coming within this week, we'll talk about how to shade volumetrics, in which we will discuss the basic shading process for your smoke simulation using attributes and principal volume shaders and create a different looks for the same simulations using different shader settings. So without holding you back any further, let's jump right to it. Now those who are new to simulations, there are a few things I wanted to clarify a bit for them. Just like how we define boundaries of a scene in 3D based on the camera angle, the boundaries of simulations are defined by a domain object within which all the information about the simulations and attributes will be generated. Now these domain objects store simulation data in voxels such as explosion or a splash, etc., and also give you access to attributes for shading purposes such as how much heat is there, what is the density of smoke, smoke color, flames, how much velocity, temperature, etc. And these attributes can be used for rendering purposes. These voxels, think of them like a pixels for a moment. Just like more pixels make a picture more defined, similarly more voxels make your simulations more realistic and well defined at the cost of performance. So the bigger the simulation is, the slower the performance of the simulation will be. Basically, the simulation of fountain will take much longer to simulate than the simulation of a small glass of water. Because of the scale, there will be much larger number of particles or the voxels to simulate. So to clarify how to set up this further, I will quickly explain with a sketch which is much faster. So let's say you have a scene of forest where few people are sitting next to bonfire. When adding simulation, you will have to think where the fire source is. So it's right in the center in this scenario. So let's create a domain object which defines the boundary of this simulation somewhere over here and make it large enough so that it does not clips off the smoke. Now try to visualize the smoke. From around here it should disappear, so you can make the box somewhere around this tall. Now every smoke simulation needs a domain and a flow source. So in this case our flow source will be these logs, the woods basically, and when the simulation is done, the box will contain smoke and fire plus few attributes like heat, velocity, temperature, density, based on which you can define the look of the simulation during the shading. So this I'm explaining in sketch because it could take long time to simulate this back and forth and do it in 3D, and it's much easier this way and much faster. Now let's jump to 3D. So let me just go back to the Blender and create a very simple smoke simulation to explain what we are talking about over here. So to create a simple simulation, what you need to do is select your source object. In this case I have this small cube and I'll just set the dimension centimeters and I'll just make this one 10 centimeters, very small object, and place it in the center. So we have a very small cube which is 10 centimeter, and now if I want to create a smoke simulation out of this, so what we can do is there is one quick way. Go to the object and quick effects, and you'll see over here quick smoke and quick liquid. These both are Mantaflow parameters setups. So if you want smoke, you just click on the quick smoke over here. Now you'll see a few things just happened. So let me just explain what happened, and we'll create this manually as well. So as we discussed, there's a domain object which is surrounding our main source object. Now this domain object, if you go to the physics properties, this is basically a simple cube. If you go to the edit mode, it has four vertices in a polygon, and it's a basic cube. Okay, what is happening is when you click on the quick effects and apply quick smoke, this takes a cube and converts that into a domain object, and also applies one of fluid physics properties to our source object. Now what I'll do is I'll do the same thing again, but without the help of quick preset, so that you can understand this better. I'll go to the physics properties over here and click on the fluid, and what kind of fluid you want. Over here you'll select this is a flow object. We want the smoke to flow from this object, so let's make this one a flow object. Okay, now I'll make another cube and place it in the center somewhere over here, and make it around this tall. Okay, I want this smoke to rise above and this will take around till around here. I think the smoke will disappear, so this length of the cube is pretty decent. So right now it's a solid cube. I'll change the display settings of this cube to bounds so that we can see the simulation. All right, and now let's take this cube and convert this into a domain and apply one fluid physics properties and change this to domain. And from here, make sure this is set to gas. If this domain is liquid and the flow source is set to smoke, then it will not work. So make sure this is set to gas. Over here, if you click on the bake data, now this will create a smoke simulation from this cube. All right, so as you can see, there is one very basic something is going on over here, a small puff of smoke. Okay, and I hope you can see it clearly. So yeah, this is because the right now the settings are not properly set up, and this is a very low resolution simulation, and it looks stupid right now. We'll make it exciting in a moment. Now right now it's not continuously flowing because the flow object is set to geometry. That means only the volume on only the smoke which is covering the volume of this object will be emitted, and that will disappear. Okay, it will not continuously flow. If you want the smoke to continuously flow from this object, then you'll have to change this to inflow. Now if I free the data and bake the simulation again, you will see the smoke is continuously emitted from the source object. Okay, and right now it's simply just rising above. There is not much of a great motion to it. That's because right now we don't have any forces or any other things affecting the smoke. So what we can do is let's increase the go to the physics properties and increase the simulation length. I'll make this 150, and let's simulate this for 150 and see what happens. Alright, so here's the simulation, 150 frames, and let's see how it looks. So as you can see, it's a pretty simple smoke simulation, nothing much happening. Like I said, there are no forces in it, and it simply rises above and clips off from here because the limitation of the domain object. So we are going to do a few more things to make it look exciting. One thing is we are going to add some force to it. So I'll click over here and press Shift A, force field turbulence over here, and set the strength to around 2 and size to 2. Okay, now let's as you can see, you can always press escape to stop your simulation and resume it from here anytime if you haven't made any changes to it. Okay, if you have made any other tweaks, then you'll have to rebake the entire simulation from the start. Okay, once we have slight forces, it looks much more natural. It's flowing in some direction, and it has some wavy this turbulence to it, so this looks good. Okay, so I'll increase the domain slightly and make it slightly bigger and place it over here, and also make sure the origin of the domain is in the center. It's a good practice, especially when you're dealing with the fluid simulations. Okay, so I'll set the strength of the turbulence force to 1. All right. So I decreased the strength of this turbulence. And before going forward, I just want to clarify a few more things. So let me just go through a few of these parameters one by one. What is happening? There is a lot of things over here which I want to introduce first before getting into any details. So right now we have two things. One is the smoke domain, one is the flow source. Okay. So when you select the domain object, there are these parameters called, the first thing is the main settings, which is the resolution of the domain. Okay, so as you can see, there is a small cube over here, and this represents the size of the voxel, the resolution division over here. So the higher this subdivision is, the finer this simulation will get, but this will get slower if you increase it too much. Okay, this resolution is not just for the visual, this is also for the quality of the simulation. It's the more the resolution is, the much precise the simulation will be. Okay, the first thing is the division, and let me just free up this bake. Okay, free data, and make this one 32 and bake the data. This is just to show you what the resolution is about. And as you can see, now the smoke looks very like a foggy, and it doesn't have a defined shape, and the voxels are much bigger, and it looks pixelated. Okay, and it still has a motion but not much of a use. Okay, now I'll just make it 128 and bake the data. Alright, so the simulation is done, and as you noticed, this took me much longer than what we simulated on 64. The more resolution you add, the slower the simulation will get, but the results will be much prettier and much more defined. As you can see the flames, you can see the smoke curls and all very clearly, and it's much more defined, and the motion is much better. Okay, it's not foggy, and it kind of looks realistic, and this is just a basic setup. Okay, and I'm sure if we add more resolution to it, like if we add more noise or upres this one, this will look even prettier. Resolution subdivision is for the physics of the smoke. Okay, and to control the visual of the visual resolution, you can always use these parameters over here. Okay, and we will discuss about this in a moment. Okay, so right now when we bake the simulation, it's taking around 1 second for each frame, or 2 seconds for each frame. Okay, now that's happening because even though the smoke is only in this area, Mantaflow is still calculating all this space which is within the domain, and that is actually slowing the simulation down. Okay, now to improve this performance, what you can do is you can use adaptive domain, which is over here. If you enable this, when we bake the simulation now, you'll see it's much faster, and this is much more useful for earlier frames of the simulation, because eventually at the later part of the simulation, when the smoke reaches its maximum height, it's going to be almost same as without the adaptive domain. Okay, and as the name suggests, the adaptive domain is basically the domain shape is adapting to the size of the simulation and saving us all that unnecessary calculations which were going to happen in these empty areas. Okay, I'll suggest you always keep the adaptive domain on, and it definitely improves your performance. Second parameter is the time scale. Okay, to discuss this, I'll just make it a 64 resolution for this simulation. On the time scale of 1, we have the actual speed of the simulation. So this is the actual speed of the simulation when the time scale is set to 1. Okay, now I can control the speed of the simulation. I can make it slower or much faster if I tweak this parameter. If you want to uh, slow it down, then you can decrease this number, and if you want to speed this up, you can increase this number. Now let's take another preview with the change this to 4 and bake the data. So yeah, this simulation is much faster, and the animation of the smoke is happening 4 times of the actual speed. If you're dealing with some slow motion shots, you can always decrease this number to like 0.2 or something, 0.3. Or if you are like happy with your simulation but you find the speed of the smoke or fire, you want to control it, then you can use this parameter. So there are a few more things over here like a CFL number, timestamps and all, but I don't completely understand the this parameter specifically, and I'm still doing my homework on this. So maybe in later chapters I'll cover these in details, but I'll just go through other few parameters over here because these are essentials for the beginning purpose. Okay, so the dissolve over here is as the name suggests, basically the smoke, as you see right now, it basically reaches its maximum height and clips off where the boundaries of the domains are. Okay, and what you can do is you can enable the dissolve parameter from here, and what this will do is this will dissolve the smoke, and you can control the speed of it by time frame over here. Okay, so let me just free up this smoke, and so I'll just make simulation again and see how it looks. So as you can see right now, we can only see this part of the simulation because of the dissolve, all that information disappears. Okay, but we were seeing the interesting curls happening, so all that is not visible because it dissolved. Okay, now you can control this one if you make this dissolve like much slower, then I think you should be able to see all those much more part of the smoke. Okay, now the dissolve is happening much slower, like previously when this was set to 5, it was from around here it was affecting the smoke, but now that we increase this number, now we can see smoke till over here, and some part of the smoke in darker areas like this, but we don't see actually it hitting the top roof over here. Okay, so you can control how much smoke should dissolve with this parameter, and it's also useful for performance because if you don't dissolve your smoke simulation, it will endlessly keep on filling your domain. Yeah, so in the main settings you have the smoke section, and because right now our flow is only using the smoke, if we change this to fire plus smoke, then we will get smoke plus fire parameters over here. Okay, so in the smoke properties, we have buoyancy density. Okay, and this basically works with the density of the smoke. The more the density will be, the much higher the smoke will rise. Okay, and the second parameter is the buoyancy heat. Okay, so this works with the heat. So the more the heat will be in the simulation, the much higher the smoke will rise. Okay, just like in the real world, in the warm environment the smoke rises much higher, in the cold environment the smoke rises slower. Okay, third is the vorticity, and this basically adds a turbulence noise to your simulation. Okay, so I'll just show you a quick preview of this one. If I increase this parameter, let's say by 4, okay, the heat parameter, and if I bake the data now, you will see the flames are rising much higher and the smoke is rising basically much higher because there is more heat. But if I decrease this parameter like a point 0.4 or something, and as you can see this is a much slower uh, reaction, and the smoke is rising much slower. Okay, now think of this like maybe a candle flame. Okay, the candle flame will have a less heat buoyancy. Okay, and if you want to make something like a high burst maybe gasoline fire or something, then you'll have to increase this number and it will generate much more energy. Okay. Yeah, so this looks like a much more flammable object and more fuel to it. Okay, so similarly, there is buoyancy density, and which basically works with the smoke. So let me just change this to only smoke simulation and bake the data for just the default setting. So at the buoyancy density at 1, this looks something like this. Okay, and if I change this to around 4, then the smoke will rise much higher, much faster. So these are the parameters, and there are much more ways you can control your simulations, and you'll have to keep all these things in mind. And also, all right. So similarly, then we have a few parameters for fire section, and reaction speed basically how faster the reaction of the burning should be. Okay, if this reaction speed is higher, then the flames will be much smaller. Okay? And if this reaction speed is slower, the flames will be much larger. Okay. Now, if I bake this. So at the default setting, this is what flame looks like. Okay, it now this is the height of the flame. Okay, it reaches till over here, and you can control this from here. Okay, reaction speed. If you want a much larger flames, then you can decrease this number to 0.25 or something, then you will see much larger flames. So yeah, and then there is a flame smoke, basically how much smoke is created with the flame. Also there is vorticity for the fire, like this noise we see. Right now we have a turbulence noise affecting the simulation, but by default the smoke have some vorticity, like some noise in the flames. Okay, think of it like a bonfire. Flames have much more noise, and the candle flame is much more uniform and have less noise. Okay, so if you want to make it like a candle, then you'll have to make it zero vorticity and bake the data, and this will look like a candle flame. Sorry, I'll just increase the reaction speed to 1 so that it's not such a big flame. So as you can see, this flame have much less noise. Okay, and I'll just disable this force field so that it doesn't affect our simulation. Let me just make it 128 so that we can see the effect much better. So yeah, so without any noise, this looks like the flame of the candle what you see. Right now it's a very low resolution simulation, that's why you can't see the shape properly. But as you notice, there is not much of a turbulence to this one. Okay, that's because there is no vorticity or noise to this flame. Okay, it looks very uniform and like a candle flame. Okay, but if I change this to in the fire section vorticity, if I make this around 1, let's make it 2 and see what happens. As you can see, there is much more turbulent noise in this one, and this result will be much more visible if I change the scale of this object, because right now it's too tiny to notice. Yeah, so this one right now it's much more clear. Flames have a lot of noise, even though we have disabled our turbulent noise, but still you can see a lot of noise in this flames. If I make this 0 again, you should be able to see a very smooth and nice flame. Yeah, so this way you can control the look of your simulation, and I'll just make this small again. And so yeah, in the smoke and fire parameters you can play around and define the kind of look you want. And also this vorticity, just like this vorticity, this one is for the smoke. So if you want to control the smoke and you want it to have some noise, you can use the vorticity in the smoke. Okay, and adaptive domain we have already discussed. Now let's talk about the noise over here. Okay, so to access this parameter noise, what you need is you first need a simulation. Okay, otherwise it will not work. Okay, it works on top of your simulation. So as we were discussing earlier, this resolution defines the physics of the simulation, and you can control the look of the simulation with this. Okay, so we are going to set the resolution to 128 for now and bake the data. And let's just wait for a while. All right, so on 128 resolution, this is the simulation we have with the same noise. And I disabled the dissolve so that we could see the entire simulation. So this is what it looks like. Okay, and this gives us the smoke simulation, the fire and smoke simulation data. Okay, and we can render this one as well, but there is one thing over here that is called upres factor. Okay, and what this does is basically adds more resolution, defines your simulation with much more high resolution data, gives it a much better look. Okay, and if I enable this noise, now this disappeared because we'll have to bake the noise. Okay, your main simulation is still there, and even if you delete the noise later, your simulation won't be affected. So enable the noise. Yeah, we leave this to 2 for now. And strength, now this parameter over here is for the upres factor. This adds more resolution to your simulation. Okay, the visual resolution. Okay, and then these parameters over here, these are for the noise. Okay, now what's happening is, what this does is it basically adds more noise to your simulation. Okay, and makes it look more realistic in some cases. Okay, so you'll have to think about this before applying. Okay, now when you enable this one, okay, if you leave the strength 1, then it will add noise. Okay, but if you're creating something like a cigarette smoke or something like a very small source of smoke which is very smooth and all, then you might won't need the noise. Okay, and you can make it 0. Okay, it will still add resolution to your smoke, but it will not affect the simulations pattern. Okay, it will not be noisy. Okay, this you should you can use when you are animating something like a much larger smoke simulations like a firecrackers and all. Okay, so in that case, this strength parameter, this can enhance the look of the simulation and add more noise to it. Okay, let's just add noise by 1 and bake the data and see the visual difference. Okay, so here's the simulation. And so as you can see, there is noise in our simulation. Right now the scale of the noise is set to 2. That's why it's giving us a much finer noise. If we increase this one or decrease this one, we can control the size of the noise, and we can also control the strength of the noise, and we can also control the animation time of this noise. Okay, this basically the wavelet noise is think of it like a overlay. Okay, now if I disable this one, you can see just concentrate on this form over here. Okay, this curve. Okay, it's working on the same form and adding more noise to it. Okay, now if I increase the scale of the noise by let's make it 6. Okay, and make this now. So I just cancel this to 47 frames. And now let's have a look at this one. So now if I enable the noise, you'll see these curls are much larger. Okay, like I don't know if you can notice the difference, but it basically over here you can see the pattern of the noise, the size has increased. Okay, now so in our case we don't want noise. We'll free this up and change the strength back to 0, and scale doesn't matter because the strength is set to 0. We are only going to use the uprest factor, and we want this to be 2. Okay, you can also make it 3 if you want. So let's bake the simulation. All right, so now as you can see, our simulation have much more resolution, and it's much more defined compared to what we had earlier without the upres. So this is the default simulation without upres factor. So when we add more resolution from here, it looks like this. Okay, so it's a very nice feature, and right now at this moment we are not using the noise, but I'm sure when we are dealing with the different kind of scenarios, and you would want to play around with all these parameters and see how these works, because whenever creating a simulation, the process could be very time taking if you're not familiar with these parameters. So once you understand all these, you will have a much clearer idea how to shape your simulation instead of just randomly hitting simulate and wasting your time randomly over, with random parameters. Okay, I hope this gives you some idea, and now let's look at few more parameters over here. And after this one we have guides, and this is a much advanced thing. And what this basically does is it can compute velocities from different objects and affect the simulation. Let's say if I had a bullet over here and this passing by, so I can enable the guides. You can use much more advanced parameters, like using the velocity of one object to affect the simulation, and also you can use some other domain. Let's say if I had one more domain with the smoke simulation, and I want that smoke simulation to affect this one. Okay, and that could work like a very realistic wind. Okay, it's a much advanced parameter, and even I haven't used it much, like not very thoroughly, so I won't discuss this at this moment. And after that we have collections. So if you have multiple objects like a flow source and all, you can make a collection of them and define that from here, assign that from here. And then we have cache, and right now when we simulate, it's saving this in a temporary directory. Okay, or this will save this wherever your file is saved, next to the folder of the file. But you would want to make sure that you give it a folder, otherwise if it's in the temp directory, when you close the blender you will lose your simulation. Okay, so now let's select the flow source. Okay, so in flow source you can define a lot of things, like first of all, whether you want this to be only smoke or fire plus smoke or just the fire. And then you can define smoke color from here, which you can use in shading with the attributes. And then we have initial temperature. Okay, so let me just free this bake and show you one more thing. So right now the initial temperature of this flow source is 1. Basically the temperature is basically positive, and that is actually adding into the heat, and that's why because of the temperature, the flames and smoke is rising above. Okay, if I make this -2, and then let's disable the noise and make it 64 for a quick preview. Sorry, I think this will work better with the smoke, because fire can't have a negative temperature, I guess. So I'll change this to smoke, and now if I bake the data, you'll see the smoke, instead of rising above, it's falling down because it has a negative temperature. Okay, so yeah, initial temperature is you can use this to control the temperature of the smoke. And then we have density, and basically it defines the density of the smoke. If I make it 0.2, it will be less dense, and if I increase this to 1, then we have much more dense smoke. Okay, so density is pretty straightforward. So yeah, so just to give you a quick overview, if you enable the initial velocity, then whatever the animation the source object have, let me just go to the front view and free the animation. So let's say if my emitter is at this point at frame 1, and at around 30 it's over here, and at around 60 it's over here. Okay, and now this object have some velocity. Okay, now if I enable the initial velocity, and now whatever the velocity of the object is, that will that I can use in the smoke simulation. So if I make this 2, it will be much more high velocity. The velocity will affect the smoke much more, as you can see. Now the difference is, if I don't use this source velocity or initial velocity, then it will just leave a trail. Uh, the smoke will not use the velocity from the object. So that is something to keep that in mind. So right now it's just leaving a trail of smoke, and it's not using any velocity. All right. And similarly, you can define like how much velocity in the normal direction you want. It basically works with the normals of the geometry. If I enable the normals in these direction, in the vertex normals, so the smoke will have velocity in these direction. If I define this, make it a 3 normal velocity, then the simulation will have some velocity in the direction of the cube's normal. Yeah, as you can see over here, instead of just a plain trail, when the smoke is emitted, it has some velocity in these directions. Yeah, so instead of just having a simple plain trail of the smoke is emit when the smoke is emitted, it has some velocity, and it bounces around, and like it has some force in the direction of the normal, in these normal directions. And so that is because of the normal velocity. Okay, so then there are a few more, like initial x, y, z. You can define in which direction the velocity should be. Like if you give it a x velocity, then the smoke will move in this direction more. Then if you have y velocity, then in y direction, and z direction will make it go upwards. So if I give it a 5 velocity in the z direction, then it will work something like a fountain. So yeah, because of the z velocity, the smoke, when it's emitted, it moves upward, but because of the negative temperature, then it falls down. So it's because of the velocity in the z direction. Okay, yeah, you can control your simulation. Velocities are very important when you're dealing with explosions. So that is something we'll discuss later when we are creating an explosion. But I hope this gives you some idea. And surface emission, basically how much smoke is emitted from the surface, and volume emission is how much smoke is emitted from the volume. So if you want to add more smoke, you can increase these numbers, and it will create a much more smoke. Okay, so yeah, I hope this gives you some idea. And just like in other Mantaflow tutorial we discussed, where we created the splash, you can animate these properties of use inflow, and you can keyframe this. If you want to disable this from over here, and smoke will stop emitting at this on that keyframe. Okay, so it will only create a spray, one spray, and it will stop where the key is. So you can also animate all these parameters if you want, and most of these are animatable. And now that we have created one key for the use inflow at around frame 25, after frame 25 no smoke is generated. Okay, all right, so just to conclude this chapter, I've set up this file, and it's a pretty basic setup, and the results are what you've seen in the trailer. Just to give you an overview what is going on over here, I have this domain object, which is a simple cube, and the dimensions are 4 by 4 by almost 8 meters. And then we have a cube over here, which is like around 0.15 meters, and you can play with the centimeters if you want. So don't worry about this noise over here. I'm just it's an old habit of giving a emitter some noise for a much more detailed simulation. But at this stage, I don't think, because the simulation is so simple, I don't think it's going to affect much, and you can keep it a simple box. Okay, so this noise, if you want to add, simply apply displace. Let me just show you one cube and subdivide it a few times, and then you can apply one displace and click on the new texture, and then select texture number 002 from the texture properties over here, and select what kind of texture you want, and so you can set the size of it, and then in the modifier properties, what kind of texture coordinates you want some other object to affect the texture coordinates, you can do that and select this empty, and now when you move this empty, it will animate your geometry. Okay, and we talked about this in introduction series, so if you're confused, you can have a look at it later. So yeah, that's your emitter object, and then I have one very simple force, which is turbulence noise, uh, just what we've been dealing with today. So, but just to add some more details to it, what I've done is I've animated the noise strength and the size. So in the real world, you can see the wind is not always uniform. Okay, sometimes the strength of the wind increases, sometimes it decreases, sometimes you have more noise in the wind, sometimes you have less noise in the wind. So to simulate that, you can add a turbulent noise, and whenever you increase the strength of the noise, there will be much more turbulence. Basically, it will animate faster, and when you have less strength, then it will affect less, I mean, to the smoke. And also, if you decrease the size of the turbulence, it will create much finer noise, and if you increase the size of the turbulence, it will create much more wavy and much more larger shapes in the noise. Okay, so I'll show you with the simulation. So I'll make it 64 resolution, and adaptive domain is enabled, and let's just bake the data and see the results. All right, so yeah, at 64 resolution, it took me around 5 minutes. So I'm just going to play this and see the results. Let me just make it a darker background. Yeah, so as you can see, because we have animated the turbulent noise, whenever the strength of the noise increases, somewhere around here, you can see there is a push to the smoke, and somewhere around here and here, and these will be much more visible in a higher resolution, and around at the end of the animation. So it has some nice motion to it, and also if you notice over here, whenever the size of the turbulent noise gets smaller, there will be much more noise to the simulation. So somewhere around over here, we have a zero point 0.4 size. Okay, so it gets noisy, but when we have some larger number in the scale, you'll see some large waves over here. So to see the results better, and how the forces are working and all, we are going to simulate this one in 180 resolution. Okay, it's totally up to you guys what kind of resolution you want, and depending on the configuration of your system. My final simulation will be in 256, and that can take a lot of time, so I would recommend you to stick around 128 to 180 for now, and it's going to look pretty good even in that resolution. So I'm just going to show you a preview of how it should look like in 180 resolution with the upraise factor. Okay, so I'll make it 180, and I'll enable the noise and enable the upraise factor. Okay, now instead of baking these two separately, uh, I can choose final simulation from here, and what this will do is it will bake the simulation and the noise these both together in one go. Okay, so since I'm pretty sure what is going on over here, I'm going to bake this all and come back in some time and show you the results. Alright guys, so the final simulation is done, and I'm just going to do a preview and show you the results. So here's the preview for the final simulation which we just did on the 180 resolution, and this looks pretty good. I think it's pretty much similar to what you've seen in the trailer. In the final render, the motion is pretty much same. That's because it's the same file, same setup, nothing has changed, and the only difference here is the 180 resolution. And for the comparison purpose, I'm just going to keep both the previews side by side. On the left side we have a 180 resolution, and on the right side we have a 256 resolution. So this one on the left took me 45 minutes for the entire baking, and the one on the right took me around 3 to 4 hours. And the results in the results, I think both look pretty good, and it's up to the requirement. The 256 resolution definitely have much more clear shapes and much more defined smoke. But like I said, it depends on the what your requirement is, and if it's for very realistic visual effects, then the more resolution works in the favor. But if it's for something like an animated cinematic, then I think the medium resolution of from 128 to 180 works pretty good, pretty well. Okay, so I'll let you guys decide on that, and do play around with all these parameters, the basic ones we discussed today, and there are much more things we are going to discuss in this series in the later chapters with the different kind of assignments. So yeah, just take it easy on this one. This could take some time to get get used to. So I hope to see what you guys make with Mantaflow, and do share your results on Instagram. Tag me with Crossmind. And those of you who are waiting for the shading part, that we will discuss in the next chapter, because that is also a very detailed topic, because we'll be combining a lot of attributes like heat, smoke, color, density, temperature, and all those attributes with the principal volume shader, and create a few different looks for the same simulation. So even though the simulation is same, you can still create you can still control a lot of visual aspect in the shading part, and give it a totally different look. And so that is a lot of fun, and that is what we are going to discuss in the next chapter. So I hope to see you guys around, and see you in the next chapter. Thank you and good luck.